Alright, hello and welcome. So we've kind of discussed that inverse functions reverse the process of whatever equation the function has. So basically, inverse functions cancel each other out. So you go back to the beginning input. So if you take the inverse of a function, you get x, the original input. If you have a function of its inverse, you get x, the original input. So this is function composition. So if you compose an inverse with a function, you get x. If you compose the function with its inverse, you get x. So this is kind of the case where f of g and g of f are the same, okay, when they're inverses of each other. Okay, so in this example, it says verify that f is 5x minus 1 and g is x plus 1 over 5 are inverse functions. So we have to do f of g of x. So we have f, which is 5x minus 1. We replace the x by g of x. And we plug in, right? So we have 5 and plug in the g, which is x plus 1 over 5 minus 1. Okay, so now we're going to cancel these out. We have x plus 1 minus 1. Cross these out and we get x. Good, so we're halfway there. F of g of x is x. Okay, so that verifies actually the second part. Yeah. Now we're going to do g of f of x. So we start with the g function, x plus 1 over 5. The x gets replaced by f of x because we're plugging f into g. So let's do that. So we get f is parentheses 5x minus 1 plus 1 over 5. Okay? So if these cancel out, we get 5x over 5, which is x again. Alright, so we can see that this one is fulfilled. So because f of g of x is x and g of f of x is x, you can say that g is the inverse of f and f is the inverse of g. They're inverses of each other. Okay? Alright, so let's look a bit closer at these equations and see if it makes sense they're inverses of each other. Okay? So this function here, 5x minus 1, this tells me take a number x. Take a number, multiply it by 5. And then subtract 1 from the result. Alright, so take any number, multiply by 5, subtract 1. Okay, so let's say I take 10. I multiply by 5 to get 50, and I subtract 1, I get 49. Okay? Now, g of x says add 1 to a number. So take a number, add 1 to it, then divide the result by 5. So notice we're doing the steps of the function f in reverse, right? So if I take this result of 49 and I add 1, I get 50, and I divide by 5, I get 10. So I get back to my input. Okay, so that's the purpose of an inverse function, is that it copies the steps of the original function by backwards in order to reverse the process and get back to what you started with. Okay? So we use inverses all the time. You've used them all throughout this class when you solve an equation. If you have an equation like 3x minus 1 equals 2, you go, how do I figure out what x to plug into here in order to get 2? So you reverse the process. You go, this function tells me multiply by 3 and subtract 1. The inverse backward steps says add 1, and you get 3x equals 3, and divide by 3. and you get x equals to 1. Okay, so it reverses the process. You're basically doing take the output, add 1 to it, and divide by 3. So it's kind of like take the output, add 1 and divide by 3, and that will tell you what number you had to plug in order to get an answer of 2. Okay, so when you solve equations, you are applying inverse functions all the time. Okay, so we're just kind of basically making this process more mathy to kind of see to apply it to other things. All right.